This is a video for to finish our section 1-2 notes. So an exponential function, so something I would say a lot with my algebra kids is an easy way to remember exponential function is the x is the exponent. So the x is the exponent. If this number with the exponent is higher than 1, it's going to grow. And if this number is less than 1, it's going to be a decay. So for example, let's say our a is 3. If we take 2 to the x power, you guys can see that's going to keep getting bigger and bigger and bigger because you keep multiplying by 2, multiplying by 2, multiplying by 2. If we start with a 3 and then we keep multiplying by a 0.5, that would be a decay and it would keep shrinking. So I'm sure you guys have remembered talking about that. I kind of drew 2 exponential functions here in the same color. So let's just do this. The growth function, it starts really, really low and then it's going to shoot up really, really high. And then the decay function starts high and then it shrinks low. So your domain would be all real numbers and your range would be always above the x-axis, so from 0 to infinity with your brackets. So that's just a quick review of exponential functions. You can write down as much or as little as you want to. A log function, here's the form, f of x equals log base a of x. A has to be a positive constant and is the inverse of a exponential function. So they kind of go hand in hand. I kind of had to review that for myself last year. So you kind of notice, look how the domains and ranges are flipped. So now our domain is 0 to infinity and our range, I could have said all reals, but I chose to write that for some reason. So they're just kind of what your logarithmic functions look like. And this is all in your book as well. Okay, and finally, algebraic functions. Let's see how the book describes this. Okay, so this is on the bottom of page 30. You can see an algebraic function. It can be constructed using algebraic observations, add, subtract, multiply, divide, taking roots. So it's kind of like a subset of a rational. A rational, you have to divide 2 polynomials. Well, we could deal with division, but notice now, you know, you can have all kinds of crazy things going on in an algebraic function. And then you see here many different types of graphs. So they have an example, the theory of relativity, which maybe ask Mr. Webster about that if you have physics. I'm not going to claim to know a lot about that. So all I did for my notes is I just kind of wrote down, gosh, I can't get my camera back. I just wrote down some examples that they gave in the book. And I also said quadratic functions are automatically algebraic. So they kind of all go hand in hand. Your domain and range is totally going to vary just based on what kind of function that you have. So the last thing I wanted to tell you guys about was in the linear functions, how to do a line of best fit using your calculator, and also how to do a line of best fit just by hand. So I'm going to show that by doing number 16. And you guys are going to have number 15 as a homework problem. So I'm going to pause and move my book. Okay. So question number 16, the manager of a furniture factory finds it costs $2,200 to manufacture 100 chairs in one day and $4,800 to produce 300 chairs in a day. So they want us to express the cost as a function of the number of chairs produced, assuming it's linear, and also sketch the graph. They want to know the slope, and they want to know what the slope represents, and they also want to know the y-intercept and what it represents. So let's see if I can get this to show up on my paper. So this is going to be number 16. So what we know is 100 chairs was $2,200, and they did 300 chairs, and that was $4,800. So I think it makes sense that chairs is your independent variable and the cost is your y variable. So all we really have, 100, 200, 300, and let's do 1,000, 2,000, 3,000, 4,000, 5,000. Okay, so 100 chairs, $2,200, 300 chairs, $4,800. And they said assume it's linear. So a line of best fit I mean, you guys should be able to figure that out from algebra. So let's kind of do that first. You guys remember y equals mx plus b. But the point slope form is y minus y1 equals slope of, oh gosh, I have to remember how to do this myself, x minus x1. That's called the point slope form. So we know the coordinates 100, 2200, and 300, 4800. So you guys should be able to calculate the slope as the change in y over the change in x. So from 2200 to 4800, that's a difference of, oh gosh, I can totally do that in my head, but 2600 over the change in x would be 200. So that would be 13. So that's your slope. And then let's plug this in. Y minus, I'm going to use this, 2200 equals slope 13 times x minus 100. And then you could get that into point slope form, or slope-intercept form. 13x minus 1300. Now I'm just going to add the 2200 to the other side. So y equals 13x plus 900. That is the equation of this best fit line. Okay, I'm going to show you guys how you could do that in your calculator. If you had a big scatter plot, this would make more sense, but you can do this with just 2 dots in your scatter plot. So if you go to Stat, Edit, and we're going to enter our 2 value points. So we have 100 and 300 matched up with 2200 and 4800. And if we would look at a scatter plot, it's okay if you don't know how to do this, but there's your 2 dots, okay? And if I want to create a best fit line, you go to Stat, Calc, Linear Regression. List 1, list 2, yes. Calculate. And there we go. Same thing. Y equals A is your slope, 13x plus 900. So this was going to be very similar to number 15 in your homework. So the notes need to be finished, and then the book problems need to be complete. And just do your best. It's a completion grade.